Hello, this is Ed Chapman, and this video cast is going to cover pH, which is our last property of water in the first part of Unit 2 about the chemistry of life. When most people talk about pH or think about pH, they probably think about acids and bases. And first thing to know about acids and bases is that they are solutes. All right? Acids are solutes that when you mix them with water, they release an abundance of hydrogen ions, which are symbolized as H+. And you can think of a hydrogen ion as a proton, okay, with no electron associated with it. So it's the same thing as a hydrogen nucleus, all right? And bases, on the other hand, when you mix them with water, these are solutes that release an abundance of hydroxide ions, which are OH minus. Just think hydroxide. Hydroxide kind of tells you it's OH, and they carry a negative charge. And the cool thing about acids and bases is that when you mix them together, the hydroxide ions and the hydrogen ions combine to form plain old everyday water. So bases and acids will neutralize each other, okay, which means they cancel out each other's ions. So when you mix them together, the hydrogen ions go away and the hydroxide ions go away, and you end up with water. As long as you have equal amounts of these, you'll always have a neutral solution. I'll come back to that idea in a minute. Now, the pH scale only measures hydrogen ion concentrations in a solution. So the pH scale, in other words, is just a measurement of how much hydrogen ion you have in a solution. But it gets a little weird because when you increase the hydrogen ion concentration, you lower the pH. And that seems like the opposite of the way it should be. Sorry, I didn't make this stuff up. That's the way it is. So when you increase pH, when you decrease pH, you lower the hydrogen ion concentration. So this means bases decrease hydrogen ion concentration and raise the pH, and acids increase the hydrogen ion concentration but lower the pH. All right? So that's one way of looking at the pH scale. The other way of looking at the pH scale is actually look at some things that have different pHs, and that's what you guys see right here. All right? Let's start up here at the top. A battery acid has a very low pH, okay? Extremely low. Okay, extremely low pH, and this makes it dangerous. Things that are up here at the top with very, very low pHs are what we call strong acids, okay? This is some nasty stuff. You do not want to get this on your skin or in your eyes because it will literally burn you chemically, all right? Down here at the bottom, we have things with very high pH, like bleach or lye. And these are chemicals that don't have hardly any hydrogen ion concentrations in them, and they have a whole bunch of hydroxide ions. And these are very, very strong or very extremely high pH. Okay, and things with high pH we call strong bases. All right, and strong bases, just like strong acids, you do not want to get these on your skin or in your eyes. All right, so when you have a pH down here around a little bit more than 11, all the way to 14, okay, you have an extremely nasty chemical. That's not something you want to get anywhere close to your body. All right, pure water is the opposite of acids and bases. It's exactly in the middle. So the pH scale goes from 0 to 14, with 7 being right in the middle. Okay. Now, this 7 here isn't exactly in the middle because they have more acids listed than they do bases. Okay, so I hope you guys can see that. So when you go up this way, less than 7, you're in the acid range. And when you go greater than 7, you're in the base range. All right? Now, the most important range of pHs for biology is the range that's very close to neutral. Okay, somewhere between 6 and 8. All right, this is where you find the pH of living cells and liquids or solutions associated with living cells. And as you can see in our diagram here, we have some things like milk. Milk has a pH of about 6.5. It's slightly acidic. Pure water, of course, is 7. Human saliva is coming in at about 6.5 to 7.4, which is a very weak base. And even your blood doesn't have a pH much higher than about 7.45. All right, so always remember pH of living things or solutions inside or around living things must be somewhere between 6 and 8. All right, litmus paper is a way of measuring the pH of a solution because it changes color. And litmus paper comes in two different kinds. There's blue litmus paper and red litmus paper. It's very old stuff. It's been around for a long time. And let me show you guys how it works. All right. Up at the top here, we have a strip of blue litmus paper. Okay, so this is a piece of paper that's been impregnated with a dye called blue litmus. All right. Now, blue litmus is very similar to red litmus. Here's a piece of paper that it's been impregnated or coated with something called red litmus. All right. Now, in the middle here where it says blue and red, they're dry, and at the ends they've been wetted. And the cool thing about litmus paper is blue litmus paper will turn red when you put an acid on it. And blue litmus paper will turn red when you put an acid on it. And red litmus paper will turn blue when you put a base on it. So what we've done is we've dipped this end of the litmus paper into a base, and you can see that the blue litmus paper stayed blue, okay, but the red litmus paper took on a bluish color. Okay, that's what you get when you dip it in a base. The red side, with the blue litmus paper, turned red in an acid, but for the red litmus paper, it stayed red. Okay. Now, I know that might seem a little bit confusing because you've got to have both colors of litmus paper to figure out what you have. All right. Now, litmus paper only tells you whether you have an acid or a base. It won't actually give you a number. Okay, in order to get an actual pH reading, you've got to use something a little fancier. All right. And in class, we're going to be using something called Hydreon paper. And Hydreon paper actually changes color gradually from red or pink all the way to a really dark greenish blue, with kind of yellow and green in the middle. And you can match the colors up to this little key and figure out what the pH of the solution is. All right, this is a little bit more advanced than litmus paper. You also can use or buy pH probes, where you just stick the probe into your solution and it will give you a little electronic readout telling you what the pH is. These can be expensive and they're very easy to break. So we're not going to be using the pH probes in lab this year. We'll be using the Hydreon paper. All right, now pH is a huge abiotic factor in the health of aquatic ecosystems. Remember, living things can't tolerate pH changes much above 7 or much below 7. And this is a problem because most pollutants in the air can acidify rainfall. They can lower the pH of the water that's falling from the condensation in clouds. So clouds that form over polluted air or in polluted air can actually produce pretty acidic rain. So in areas near especially coal-burning power plants or places where there's a lot of cars, you can get lots and lots of pollution in the air, stuff like smog, and when rain falls through this material, it can become acidified. And acid rain does a couple different things when it falls to the ground. It can kill plant life, it can pollute rivers by lowering the pH, and it actually can eat away at some stones, especially things like limestone. Acid rain, when it falls in lakes and rivers, streams, and things like that, it can acidify them. And this is particularly hard on creatures whose babies or whose eggs are very thin-skinned or don't have any shell at all. And of course, here we're talking about amphibians, things like frogs and salamanders. These guys lay eggs that don't have a shell. So they literally get pickled by the acid when the acidity of their ponds, lakes, streams, mud puddles, swamps become acidified by falling acid rain. Okay, so this makes salamanders and frogs what we call indicator species. When they disappear from an ecosystem, that usually means there's a pH problem, which probably means there's pollution messing with that ecosystem and making it difficult for these animals to live there by destroying their eggs. All right. That's it, and thanks for listening.